Hey everyone, in this video we will be comparing the both open source models from OpenAI, which is GPT OSS 120 billion as well as 20 billion model. So I'm going to test them online. In case if you want to go to this interface, you can just directly go to this particular link gpt-oss.com and you will be taken over here. And here they are having the option to toggle between the models and also customize the reasoning level also. And I am having here a lot of coding prompts, and also I'll be testing it with some lead code problems, and let's see which one performs well. So first let's begin with the spinning rectangle problem. In this I'm asking it to give a HTML code in which a rectangle will be spinning and a ball will be bouncing inside it, and this ball must be affected by the gravity friction when the rectangle rotates. Quite a famous prompt. Let's see what both models gives. So we have got the response. The OSS 120 billion model thought for 26 seconds, whereas the 20 billion model just thought for 21 seconds. So let's try running the code. So first let's go with the 120 billion model. Just copy it, and here I'm having an online HTML viewer. I'll just paste this code, and here as you can see how perfectly it has created. The rectangle is spinning and there is a ball positioned well inside it, and it's beautifully moving and responding to the gravity and friction of that rectangle. So the 120 billion parameter model has done a perfect job over here. So let's see what the 20 billion model is going to do now. So I'll just copy it and go to the same HTML viewer, paste it. It has also done an amazing job. This is the 120 billion and this is a 20 billion model. And even DeepSeek's R1 model at first failed. Only the improvised R1 model could replicate this prompt, but this model, the 20 billion parameter, has done an exceptional job over here. So both of them have performed this particular prompt well. Let's go with another one, and next is going to be a recreation of rain simulating lightning effect continuously, and this must be hyper realistic. The challenge is replicating this rain effect just by using HTML, JavaScript and CSS. So we have got the response from both the models. It has thought for 23 seconds and the 20 billion model has just thought for 8 seconds. That's a lot of difference. So let's see trying the code. We'll copy it and go here, paste it, and we have got the rain effect over here. The rain effect looks so good, but I don't see any. Okay, we got the lightning also. We have got the lightning also, and the lightning effect also looks so perfect, like that zigzag theme effect. I would like if the lightning occurs much more frequently, but this also does the job. The lightning effect is good, the blink effect is good, and the rain effect is perfect. So now let's go with the 20 billion model. Copy the code, go here and paste it. Okay, it has done a good job, but I'm not pretty much impressed with the rain effect. And here you can see a difference, right? The lightning over here was actually a line. You saw that, right? There was like this zigzag line, but here it's more of like a blink effect. Like imagine you are turning off a light and on. That's it. That's a maximum effect you can get over here. But this one looks more realistic, especially the lightning part. It was perfectly executed. So for this prompt, I will go with the 120 billion model. And next prompt is going to be code a big bird using HTML, CSS and JavaScript. Show the side view of the bird when flying. Let's see what both gives for this. So we have got the response for our flying bird prompt. Copying the code and let's see what it looks like. Okay, I don't see any bird. Okay, the bird has come over here. I mean, why is the bird going in the reverse direction? I mean, I'm fine with the appearance of the bird and the sky. I love the gradient, everything, because this is just HTML and CSS, right? We can't expect too much. Only thing is the bird is flying in the reverse direction up, and apart from that it looks pretty much good. So now let's go with the 20 billion model. Copying it, going to the viewer, pasting it. Okay, it has also got that same backdrop, but I don't see any bird over here. So I guess for this prompt the 120 billion parameter model wins. So now let's go with the lead code problem, and this is an extremely hard problem, valid number, and the acceptance rate is just 21%. So it's a crazy hard problem. Let's see what both the models does for this. Not only it has given us the code, but it has also explained entirely the solution. As you can see, it has given the pseudocode, the scenarios, proofs, so much of stuff, and finally it has given us the code. Not only for the 120 billion model, even the 20 billion model has a very good explanation. So first let's go with the 120 billion model code. So I will just copy this, the function alone, and go to lead code, remove this and replace it. Yep, that's good, and submit. And damn, it has beat 100% in the runtime. It has beat everybody in the runtime, and when it comes to memory, it beats 45%. That's insane stats from the 120 billion model, because this is an extremely hard problem. So let's go and see with our 20 billion model, and just paste the code over here, and we can remove this void main function, and we can even just remove this one, the class solution, and remove this fully. Yep, I guess that's good now, and we need an extra curly bracket. Okay, let me just submit it now. So we have got the result, and similar to that, it beats 100% of all in the runtime, and in the memory it beats 24%, and I guess we had around 40 odd percentage in that, but almost same. But imagine this is being an extremely hard problem, and this model is 6 times smaller than the 120 billion model, and still it has done a pretty good job. So in my opinion, both the models are performing exceptionally well, and the fun fact is that the 20 billion model is not bad at all. It's performing almost on par with the 120 billion model. That's a great part, because this model is 6 times less trained, less parameters than the large model, right? So we need to also like have an assumption that at least it will perform 2x lesser than the 120 billion, but it's performing on par with the 120 billion model. So that's my thought, guys. Do let me know in the comments what you think. Check the playlist of my channel. Done a lot of videos in programming and AI tools. Subscribe me. Thanks for watching.